think we're live. Good morning. So we're back at the MPCNC. It will probably be a little noisy for parts of this. I've got a new camera. This is a Microsoft Livestream. The other one was a Logitech C720 or 640 or something like that. So let me know if that's any better or different. I think it has a little bit better focus and angle of view on it. So maybe that's a little better. So I'll point out some of the things that I built here in the past that I may or may not be using anymore. So these little blocks here were my stops. And they fit in these are drilled on 1-inch centers, these holes. So they would wedge down in there, and so you had up against the pegs, or you had a little spacer so you could reach close to the next set of holes. And that gave you pretty good adjustment for just wedging stuff in. So what you do is you put a clamp, or you put a block, and put a block, and then whatever you wanted to machine, let's say a little piece of wood. So you put your little piece of wood in there, and then you'd put 2 of these wedges in and drive them against each other to wedge the part in there. So like this. Obviously, I'm not going to machine it standing up like that, but if I couldn't reach it that way, then I'd put them this way. If that still wouldn't reach, well, then I'd have to rearrange and get something. And these work okay for flat stuff, just straight on the deck. It's not too bad, but what I found is that these wedges, I mean, you can drive them in there really tight and they hold, but it doesn't hold it down. So I needed some way to hold them down. So where'd my other screwdriver go? Come on, out of there. So I came up with these other, yes, and I cut myself last night, other method which was these pin clamps. So these have a little bit of a gap that raises the part up off the table so I could use it to cut through without cutting into my board. And so I have 2 styles. One has just a single hole, right? And so that would be the zeroed end. So you push it hard against that, and that's a hard locating to these 1-inch locations. And then this one has a slot, so that gives you some adjustability, and there's up to 1 inch of adjustment on that, and that way you can accommodate various work pieces. You should be able to get anywhere and push against that one. And you could also use it for, like if you had a round piece, you could use a bunch of these to clamp the piece down. And then they have these retention screws that go through this little vertical part, and I put them at a 15-degree angle to drive it down, but you can see it's only hanging on by maybe a 1/16. Maybe you can see that. If I get my fingers out of the way. Anyway, it's not hanging on by much, and the angle's a little too steep. So what I did was I reprinted all of those. So I'm going to be, these are going to be tossed, but that's rapid prototyping. dropped a screw or a spider just went running across the floor. So right now I'm using these sheet metal screws to clamp them down into the holes. And the sheet rock screws are for the pin retention part. But I bought a bunch of these threaded inserts, but I've got to go back and line up and recut all these holes in my board to be able to insert all of those. I bought 100. I may not have bought enough. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess I need to order a couple more bags. I didn't count them. I forgot how many holes there were. So this machine can reach 11 inches by 17 inches. So 11 inches across. Actually, it's a little bit more than that, but that's safety margin, so I don't run into the gantry, because it's built without any end stops. And so if it runs into an end up against the gantry, it's going to lose steps. So those could go away. So I've printed out new parts. So these get them all out of there. So I've got 4 new pieces for the stop ends and 4 new slotted ones. The old ones also, the heads of the bolts were a little proud, so I recessed them a little bit more, and then I've changed the angle. So that's just a 5-degree angle hole coming through the side. So that should give us a little more bite in the work. And really, we're just using the sheetrock screws. Get that in there. To prevent it from lifting out. So it doesn't have to bite very far, then that's probably too far into the wood. You're probably only going to bite just a little bit. Just enough to keep it from lifting out and messing up on you. So that'll be the next project. I'm going to go throw this in the firewood box, and we'll get started. The other thing I printed out is a whole mess of these little guys. So I've got these slots. So I've got a dust collection system hooked up to this. There's a duct back at the back, and it sucks the sawdust down through, and it actually works pretty well, but the sawdust can just get flung out beyond these slots. So I'm going to put these little walls, put these little brackets, and make some little walls that go around there that just keep the sawdust from flying out completely. And we'll get that all set up. So that is probably the first order of business. Let's get these guys cleaned up. Oh, and I printed a new, so this is printed in PETG. All the rest of these, you see what I'm pointing at? All of the gray pieces on this machine right now are printed in PLA plastic. and that's what caused some of the play. You can't. Steppers are off right now, but there's a little bit of rock in the gantry there, and that little bit there translates to 1/16 of an inch at the tip. I mean, there's going to be some flex to this thing, but that's too much. The x-axis actually is still, I don't know why this one warped or whatever, but anyway, we'll get that taken care of. This is going to come out, and we'll put a new bracket on there. We'll get these guys cleaned up. We'll do some upgrading. I don't know that I'm going to take this whole. I'm going to look at this and see what I've got to do to get that part out of there. So basically, there's two screws. On here, on each of these blocks that are holding this pipe in place. And that means undoing all the electronics, the cabling, because these are not plugged stepper motors. Oh, that's going to be a pain. It's going to be a pain in the butt. Yeah, because I've got to basically disassemble this whole thing to get that out of there. Okay, that's going to be another day. That's a whole day's project all on its own. So yeah, the heat from just the router has already softened this PLA plastic for this clamp, and it's not very tight anymore. These screws that we're providing the clamping aren't actually doing hardly anything. So it would be smart to take the bit out of there before I drop it. Make a horrible mess out of something. Probably would have been easier to do this while it was in the machine. Oh boy. Okay. Well, so work on it. Wow. Yeah, I know. It's a lot of struggling. This is live, not scripted. That's for sure. Okay, there we go. Whew. Doggies. Okay. Set it back there for now. Router bit wrench away. So there's 4 screws that hold this on. They're just 1/4-20 screws. If I can find the head of it. Here. Get that taken off of there. Probably should try the new clamp out on the router body before I get this all taken apart. I'm fairly certain that it's going to work. So, yeah, that goes in like that. That seats up against that shoulder right there. And then that'll clamp. Yeah. That's going to work well. So this also has a little quick clip retention device, so I can snap that up in there and it'll stay by itself. I don't have to hold it while I get all the screws into place. That's the laptop fan working so hard. Oh, hey John. Sorry, I can't see the chat from where I'm putting screws in. But I will come and check on you after a little bit here. Oh, you do it. You do it is in the house. All right. There. Whoa. So, there we go. That comes off. And then this one. Goes right on there. Put in bolts. Yeah, we'll have to fix that another time, because I basically have to, this bracket, we'll have to fix that another time, because basically I have to disassemble all the electronics, the cabling and everything to get at that. And as long as I don't take super heavy cuts, it works for right now. And I'd like to get most of my other upgrades done to it, because eventually I want to reprint all of these in PETG just to keep this from happening. So I've got a bunch more pieces to print, and if I'm going to take it all apart, I may as well replace everything all at the same time. But until then, I'm having fun playing with it. So you know how that goes. Got upgrades planned, but I want to make stuff. But it'll probably take me a month to reprint everything again. It's just I get 11 hours of print time. I remember how long it took me to print all these pieces the first time. I'm going to say the better part of a week. There's a lot of pieces on this thing. Okay, we've got that. Now we can mount the router body back up. Yep, and that was the other thing. I originally had planned to do a 1.5 kilowatt water-cooled spindle, but it's just too darn heavy for this single lead screw and stepper motor. It probably would do it, but boy, it's going to be working really hard. And I thought, well, this is good for little projects. I'll build myself a bigger machine that can maybe cut metal with that spindle, and it'll be a different design, because the one thing about this is all these open rails. You know, sawdust is not too bad, but if you got to have coolant and other stuff to cut metal, it really needs to be well designed to handle that. Your electronic, you know, your stepper motors should all have covers, be protected. Electronics should be protected. You guys should have chip control in place so you can get the chips off of the work, recollect and recycle the coolant. Okay, that is in there. All right, let's put all of these guys down in the drawer, the box that they came out of. All right, so I have 4 more of these in various configurations into the trash. let me turn on the dust sucker, and I'm going to clean up all this sawdust first. Before we get down too far. I know this is exciting live stream. Dust collection, Tony. Yeah, I'm going to pick up the laptop and try and help out the little poor fan that's probably clogged with sawdust. This poor thing. What else we got here? Oh, hey Don, John. Oh, Dima 34, yeah. Thanks. Yeah, I liked it. I catted that up, so Ryan did a really nice job. I hope you guys can hear me over the sucker. I'm almost done. So yeah, my mount, Ryan's original design, that's just a flat mount. There's no retention device on it, so when you go to put a tool on, you have to hold it up there and get everything lined up and put the screws in. So I made a little tapered dovetail to hold that in place while you put the screws in. It makes it so it's, fortunately, the dovetail is in the part that does the tool holding, not in the base. So it doesn't alter the profile of his original base. So if you use my redesign, it will still fit all of the old tool mounts that you happen to have for it. But the original thing reason I made that was because I have a laser module that plugs in. You can't see it. The power supply for the laser module comes up here and plugs in, and this will just snap on, and I can cut stuff. I've got a pen holder that'll snap in there. So, but I probably won't be using that this time or anymore. And this is a holder for the Dremel. So this has a tapered dovetail, and then there's a little spring lever right here. Tapered dovetail and the spring lever right there with a little ear that clicks it in, so it'll hold itself up there while you make your connections. I don't know if I put that up on Thingiverse or not. Let me go let the cat in. He's hungry. I'll be right back. Okay, I'm back. Got a glass of water while I was at it. So, talking makes me thirsty. All right. I'm going to spin your guys around so you can see my messy shop. What I need to do is make some walls for those little brackets. Oops. These little brackets that I made, I showed off earlier. So they've got a little slot in them to accept some of this polypropylene that I've got a boatload of. And so we need a couple pieces. One, they're going to be 5.5 inches or 5.25 inches tall. It'll be 19 inches long for one and 25 inches long for, or 19 inches long for two of them and 25 inches long for two more. So let's see if I can do this without hurting myself. Let's get rid of these. That stays there. There was a bolt in there. Screw. Okay. Well, let's see what we can do here. We need 5.25. This may not be right. Let me switch this over. Yeah. I've got a temporary network cable. Yeah, it's full of crap in here. But I got a couple pieces. So that one's 23 by 18. Well, I used this one for testing the laser on. That one's still a good piece. So let's cut them lengthways. Ready with 911. Two of these, we got to make 19 inches long. Nineteen and a half, actually. Yeah, it's the kind of shot where you move the plug to whatever you're working on. Safety first. Yeah, you betcha. My biggest problem is don't trip on anything and fall face first into the table saw. All right. Now, I probably need to find some screws. Oh, I've got so many things in here. These look like prime candidates. Sorry, get turned around there. I don't know if that's tall enough for you guys to really see. Maybe. Switch in a little bit that way. Well, you can see most of what I'm doing anyway. All right. So there's a set of slots right down along here that we're going to try and get first. But, all right. And then I don't have any slots down here at the far end, but I just want to put a little wall up just so I can sweep it that way. Maybe I'll start with that one first. Get my purple pen. I know it looks pink, but so basically I want it to fall right along there. That little box, so oh, I know this is going to drive people nuts. Do I need to clean the flashing off of these little pieces? I probably should. Make it look snazzy like the rest of the machine. Like somebody actually cares. I'm not going to do this on camera because I sliced my finger open yesterday. So, what are you guys up to today? I see you typing there in chat. Oh, let's see. 1, 2, 3, 4, 5. We're going to need 5 for each end. So these are really basic little part. So it's just a simple profile that I extruded and then put a hole down through. Oh, I should probably check. Oh yeah, that's going to be plenty fine. Okay, I've got a drill, got a driver on the drill. That'll work. These are not, I could actually, let's swap drills. Yeah, that one might work a little better. Yes, it's Ryobi town around here. We got Ryobi batteries for everything. So. And you guys are still looking at the ground. There you go. Sorry. You yell at me. Don't you wish the chat function had a bell feature? So you could say, hey, your pants are on fire, or hey Tom, look out. You're going to drop that box of bolts. Okay, I think for this end, so the idea is that I want this to be sturdy and hold up here, but I also want to be able to remove it quickly. So if I have longer stock, let's say I'm, I I don't know, making kayak paddles or something. You could hang it out the end and get this out of your way. Okay. It's got enough room. May let some stuff get down through the crack, but it's going to block 90% of it. All right, let's do the back side. 1, 2, 3, 5. Now, before I go hog wild on this, let's see. Yeah, the gantry, none of the pieces are going to hit the slots back there. So if we get this done quickly, what I want to do is carve. I got another piece of 2x6 down there on the floor. I want to do the 3D carving of Mount St. Helens. I've got a guy working on getting me some 10, 12-inch rounds of logs, about 2.5 inches thick, 3 inches thick, something like that. The idea is I got the design all made up for making like a little bistro table where you carve out Mount St. Helens or whatever mountain or whatever piece of terrain. It's got a compass medallion motif to it, so it's got 8 arrow points. And I haven't decided whether I want to put a little banner, plaque, whatever you want to call it, with the name of the range or... Oh, what router is that? That's a rigid R2401. So they had went from Home Depot. It's 99 bucks. They had Makita. Most guys are using DeWalt 660s. But this came with a lifetime warranty, and I thought since it's going to be running for hours and hours and hours, that might not be a bad thing. The only thing I really don't like about it is that it's got a single split collet. So instead of being a well-balanced collet, it's just got one slot for pinching the, a slot down one side for pinching the bit, which is not the greatest. Okay. Oh, I forgot. I set the lock on this foot. That's locked. Yep, that's locked. That's unlocked. Yep, that's unlocked. Okay. So, pivoting you guys around. So, this whole machine is mounted on top of a Harbor Freight cabinet. When I get back over to that side, I'll show you what it's mounted on. Basically, so when I'm not using it, I can move it out of the way against the wall, and then when I want to use it, I bring it over next to where my dust collection system is and plug it in and go to town. Okay. We want to be Just right down along there. Whoops. Well, this is the short guy. What do I do with my longer pieces? All right, get you out of the way for right now. So these are not quite long enough, but that's okay. I'll make longer ones later. And they're good enough for right now. See me over here? Probably not, since I moved that into the way. Let's set you up right about there. Maybe? Oh yeah, there you go. Oh, we got more people. I can't see the chat because I'm back here behind the machine, but I'll be back around in a little bit. So, ow, ow, ow. No blood yet. Come on. So the only thing about this particular drill is I wish that the trigger was a little closer to the head. Yep, that one's going down the dust collector. I probably, it would probably be a smart thing to put a little mesh over that thing so it wouldn't keep collecting screws. But nobody's ever accused me of being smart. I know, you guys are watching me fiddle with this. Going, why don't you just drill a hole? Okay. Whew, that was work. Hey. All right, two more, and then I'll be back around. I can check on the chat. Come on, what are you doing? So the idea with this table with all the holes in it and the slots and things is that it's held in place, it's pinned, but then it's also held down with six screws. And my idea was I built this base on top of the cabinet, the chest, deep enough that I could build a fourth axis and mount it down below, so I could do some crazy stuff with round pieces. Okay, a little wavy, wobbly, but that's all right. Just gives it that handcrafted flair. Okay, what? Let's see. Ed Mike, hey. And Walter, howdy. Country 3D here. Okay, yep, I'm drilling holes and cutting things. So here's an overview of what the machine looks like. So it's got my laptop. We got the mostly printed CNC set up here on this riser. It's all set on a little, what is it? The Yukon chest. So you got storage for all your tools and bits and stuff. And then if you look back behind here, I 3D printed some ductwork. So the actual machine hangs, 6 inches off the back. But then the ductwork goes up there to allow for suction. And if I want, I can make this whole panel comes out. And if I want, I can replace this whole setup in here with a vacuum table and hook up the shop vac and still have dust collection, but have a clampless type of setup so that you can hold your work pieces without clamping. This is so weird. I am not used to this, adjusting the camera on the stream and having it be backwards. Okay, now I think, what did I do, 5 back there? Did I not print enough? 1, 2, 3, 4, 5. 1, 2, 3, 4. 4. Oh, I set some down over here. I knew I printed a whole slew because I thought, oh, I'm going to break one or lose one. So Walter, this is just giving me more dust collection. Instead of flinging dust everywhere, it'll all go down through these slots to my dust collector. So these are just little walls to help stop it from going into the laptop fan quite so much. And it's not going to collect everything, I know that, but if it can help a little bit, just keep it from going everywhere. You know, I'm messy enough on my own as it is. Right now I'm just trimming. I printed these with a brim because it was late last night and I didn't want to sit there and watch the whole first layer go down. So I watched until the brims are all printed and it looked fine. So then I went to bed. And they did. They all printed fine. All right, as long as the stream stays up, which I don't know, the chat keeps disappearing. Oh, let's see, who else we got? Tala 3D Prints. Hey, welcome. Yeah, 3D print and CNC. Yes. Well, there's more in this garage than just 3D printers and CNC. There's table saw. There's a chop saw. There's welding. There's right behind me, right back here is a bandsaw, wood cutting bandsaw. Over there is a metal cutting bandsaw. There's a drill press. There's a chop saw. There's a still, which I haven't fired up yet. That's another project that needs finishing. But you know, I'm a few years away from retirement, so once I get retired, I'll have all kinds of things to keep me busy. I'm sure the honeydew list, my wife has probably already started it for when I retire. No, I'm not taking super amounts of time to make these super pretty because I imagine that they're going to get broken. I just want them presentable. Plus, I needed an excuse to try and cut my finger again. Okay, last one. Then more screwing. More screw driving? Is that the proper term? Is it screw driving or just driving or just screwing? Well, some people would say that that's not proper. Well, I'm just going to eyeball this. Let's see. Can't even get into my shop because you're old and lazy. Yeah, well, I'm definitely lazy and I'm messy and I got to get this place cleaned up. But let me scooch. Can I scooch the laptop over? Maybe. Not really. Well, let's aim it that way. Maybe I won't knock it off of there. I'm going to try and do this end where everybody's sitting here. So let me back it up because otherwise I'm going to knock the camera off of there. That would not be fun. That might be fun, but all right. Yeah, I'm just eyeballing it in line this time. Because that's how good I did with my measuring over there. It'll probably turn out way better. Come on. I'm going to get more on this side. That's all right. Come on. Yeah. Yeah, I know. It would be smart to pre-drill the hole. But persistence. That's way out of kilter. All right. Sorry, I don't know what you're looking at, so might not be seeing anything. Might be seeing my bloody stump wave around it. Here. Okay. there's that one. Wow, that's going to be a tight fit. I got him in there so crooked. Okay, there. Not hitting on the bearings. Yay. And it's inside the slots. All right, well, since that worked so well without drawing a line, I think I'll draw a line for this one. It might help me just a little bit. Maybe. Okay, now can you see nothing? Got the cord for the camera, shut the drawer. Yeah, perfect. Okay. We have fun, don't we? And my wife thinks I'm nuts, but this is fun. I think it's fun anyway. She wonders who I'm out here talking to. And really, I would be talking to myself if it wasn't for you guys. I'm glad you guys all joined today. I know I was streaming last night while we were having the Friday 3D printing community hangout. Boy, that's a mouthful. And I couldn't stream. I really just wanted to document my first cuts, so I wasn't really worried about anybody watching it. Well, not like I'm worried about anybody watching it anytime, but I just wanted to kind of record. That was my first attempt at using double-sided milling. Mill halfway down through, flip the part over, come at it from the other side. And it worked. It relies on you taking careful measurements and telling the computer exactly the size of your workpiece, because the computer is going to base everything with its numbers as precisely as possible. And if you screw up and tell it the wrong number, well, then you're going to be off by that amount. Okie dokie. Last little bracket. And really, this is an excuse. So I want to do the St. Helens, a test model. So I'm going to, I want to make some sawdust and see how well these things work, right? I mean, that's what they're there for. We got to make some sawdust. All right. Oh, I got one extra. Yay. All right. That can go in the drawer. And these are easy enough. Well, at least this one's easy enough to remove. Okay, I'll be right back. I'm going to put the screws away, and then I'll get things rearranged so we can put the clamps in, get a piece roughed out for. Let me get the laptop put back where it belongs. Get things situated. Okie dokie. So, all right. Who else have we got in here today? All right, John Mack. And yeah, measure twice. Fits like a glove. It's not maple plywood. Hey. Hey, don't be criticizing until you built one. All right. Now, it's 7-layer birch plywood. Cheap stuff that I found at the local Sherway. All right, but let's see. What do I do with my clamps? Clamps. Thin clamps. Whoa, that was almost a disaster. Okay. Set this down here. Right now, I do have a little bit more cleanup to do. I'm probably going to print out a few more of these pieces. This is like the bare minimum for doing small stuff. So what I want to check is, whoa, what do we got there? Snap that back into the carrier. So I don't have a chain, a cable chain, but I printed these little clips so I can hook the power cord into, and I've got some nylon tubing to kind of help support the thing, and it does a pretty good job. Okay, so that keeps that out of there. All right, so we can go down to right there. So that means this row yeah, I can get past the middle of that row. So I'm going to put in 2 of these. Did I bump the camera? You can't see what's going on. I'm a little too close. Well, you're not going to. I'll show it to you after, because if I put you where you can see it, you're going to be right in the way. Okay, there's one. And get my chunk of board. Oh, whoops. Might have put that in the wrong spot. Let's see. No, we're good. We're good. So, yeah. That one can go right there. All right. So we're using these little short guys are the fixed ones, and then the slotted ones give you some adjustment for various pieces. But I need some more of these guys, so I may start another print with maybe another set. So they give me 4, 8, maybe 2 sets. If I do 2 more sets, they give you a bunch, and they give me, you know, because if you do something 17 inches long, you want support every couple inches or so. Now this probably won't work well for thin stuff, but thin stuff you're going to put a waste board under it anyway to keep it from chip out from the backside. So if I made the waste board be the clamp and screwed the stuff down to that, use a piece of plywood or something, that'd probably be all right. Put this guy right there. So that is about 8 inches. And move it back one. Oh, I may not have recessed this enough. No? It feels all right. Feels like it's down below the surface of that. Yeah. So you can see my board has quite the bow to it. So you clamp it in here, you know, curved side up, and skin off the top, and then flip the whole thing over. So that's probably what we'll do first off, and that's kind of a manual machining operation. At least that's the way I did it last time. Oh, I'm gonna get one of those. Have one of those guys get in there. So that will give us some sawdust to check, see how well the little walls work. Then I've got to go resize a St. Helens model to get it printed, get it sized right for this board, so I can carve one and test carve it and see. So I've got my bits that I've got. I don't have a huge selection. So I've got a 1/4-inch ball nose, a 1/2-inch ball, or no, 3/8 ball nose. That is. Yeah, 3/8, right? Yeah. 9.5 millimeters. 3/8 ball. Another. Oh, a V groove, a chamfer, but it doesn't cut to a very sharp point. That's a half inch. Yep, half inch flat and a deep cut half inch flat. I've got a carbide burr, which I think that's a 30-degree. And then I bought a 90-degree 1/4 inch bit. And I don't have any other like reduced shank. The other bits that I have were ones for my Dremel, and they're all 1/8 inch shank bits. So that's kind of what I'm up against. But what I was thinking is if I do it with the ball and I don't like the level of detail on it, I can go back in with the V-carve and recut it, do a finishing pass or whatever with it. Did I finish cleaning everybody? No. So let's see what it looks like. I think for terrain, the ball end mill is going to be pretty okay. I wish I had a 1/8 ball, you know, a 1/4 inch shank with a 1/8 ball, and I may order one of those. Because you'd want them for doing smaller projects. All right. Birch, yep, it's a good stuff. All right. And everything's out from underneath there. So roughly there. Now, on the other piece that I did with the Domo, the little Domo guy, that's what I did last night, which he's right here. Didn't turn out so well. He missed my tabs and stuff, but it's a good first test. But yeah, you got to look for really clear wood with not a lot of knots, otherwise you get chip out like that. Anyway, he was fun. Put that right there. So yeah, this is why I don't have time for upgrading 3D printers, is because I got other machines to upgrade and get working. It's a gateway. 3D printing is a gateway drug, but I was already a machinist before I started 3D printing, so. All right, how long do we want this? I want to miss that knot as much as possible. And the knot goes down. Of course, there's another knot there. If I use this end, I got two little knots. But this side looks pretty okay. I'm going to cut him off right there through the knot. So I get two kind of good chunks. And just a smidge. Yeah, I know. I got 2 more to put on the ends here. Or maybe 1. No, we'll put both of them. Why is it the gantry is always where I want to be? Nope, that's not gonna work. Oh, come on, you. Maybe that's a little snug, or the bolt's a little big. I don't know. Screw. Okay. It's getting warm out here. It was 90 something yesterday. Oh yeah, it's got to be right at the edge of there. Okay. You're not in there all the way yet. There we go. All right. And one right there. Move this in a little bit. Okay. Okay, last time I did Domo, I trued up the sides first before I started truing the top and bottom, and I think that was a mistake. So this time I'm going to true the top and bottom, and then I'll run it back over to the table saw. And true up the edges. And then we get a measurement for how big the stock is and feed that into the computer. I did throw them back in here. All right. Can you see that? Kind of. Maybe I need another block under there for you guys to be up a little higher. All right, let's put this in place. Get him snugged into the corner. And push down. And then we tighten up those screws. There. And this is the only one that I got to remove because it's a pain. Okay, well, that's that humped up wood. It's barely biting in there. But I think with enough of these guys, there's enough material held in there that it will be okay. You know, this would be a lot easier to put together if somebody put those in a straight line. There we go. Okay. Nope, that does not hold in there. Why did you not hold in there? Okay, let's try this again. Back these guys up. Well, it may take a couple redesigns to get these clamps where they need to be. All right. That side's good. That side's not. Okay, now that's got it. That's not doing anything. But those two are. All right, well, we're going to just take light cuts. So this is just to make some sawdust so we can see if it collects. I'm not too worried about it. It's not, as long as it won't shift around, it'll be all right. Okay, before I put this one in, Let's put a router bit in here. What's this guy? There you go. There we go. All right. Power's on. And I don't think you guys will be able to hear me, but once I get everything going, I'll mute the mic. This thing is loud. I have both dust collection and the router going. All right, we're going to cut some stuff. I'll have my hearing protection on. Okay. SL cam fired up. Stream may take a hit. Controlling it. I'm going to set you guys over here. You'll have a mostly spectacular view. Oh, I guess I better mute the mic too. pretty good job of keeping 85% of the sawdust in there. So I had this all cleaned up. So yeah, you can see a little bit of sawdust on my keyboard where it blew out of the corners. But you know what? I can print some 3D printed pieces that will go around in the corners and maybe help hold that in. That would collect even more. The only place that it really collects is down along the end there, and where the vents are, it did really good. So I can make these longer pieces. I can cut some more long ones. That'll help some of that. But yeah, I think that worked pretty well. And you know, it's not the super flattest because, like I said, I've got a little bit of give in the gantry. But now that's, at least it's flat, not so humped up and curved. And that should work well. Cool. So, who wants me to keep the string going and do Mount St. Helens? Or are you tired of listening to me? Is anybody still here? There's two. Says there's two still in the chat. All right. So if you want me to do Mount St. Helens carving, it's going to take me a minute because I got to get the model up and get the program written. And right into the keyboard. Perfect. Okay, so that's sitting down in there nicely. Let's see if these... Okay, so I got to make I have to make some new clampy pieces. Screws are too low. Don't bite in high enough up is the problem. Once I have that right up against there. All right. Yeah, radius on that wood. All right. Well, the end ones are good. So these side ones give me grief. All right, taller clamps, taller clamp blocks, redesign them again. Yeah, they just need to be angled taller and probably just flat angled. Fortunately, we're not going to go down in there that far, so. Let's see if we can get this where it's reasonably safe. Okay, that's not going anywhere. Take out that bit. Okay, and that bit. Okay. Excuse me. All right. And no, I'm not truing up the edges, because what I'll do is after I get this carved, I will cut it out and make that nice. Okay, let's see if I've got the model out here right now. File. Open. Oh. Look through all my files here. I do not have it. So let me go get the memory stick and we'll set it up. Let me take a measurement. So it can't be more than 137 by 199. dokie. Let's see if the stream's still up when I plug this in. Uh-oh. Walter's giving something away. Everybody head over there. I don't know what Walter's giving away. Oh, Star Trek ship. He's giving it away. Okay, let's open this. Millimeters. What? Okay, so we want to rotate it to the right. It's 122 by 179. And we're going to do free machining on it. And we're going to rough it with a 1/4-inch ball. We're going to finish it with a 1/4-inch ball. Rough it linear, going with the grain. I'm going to do a 50% step over. And 10% on the finish. I'm going to leave 0.8 for finish. Sure that my speeds and feeds on that. So we're going 480. Yeah, and I think I upped that to 600. 600 or 720. I think it's 720. Millimeters per minute. Plunge at 50. Might slow that down to 40. And I think that's all good. All right. We'll make a program. And we're going to put them in documents. Nope, let's put them under downloads. Save that there. Okay, now we get the beggy message from Esselcam. Oh, drank all my water. 12 seconds. All right. And the finishing pass, we got 20 seconds for that one. Move the camera again. And we can check. Get you right down in there. Camera. How's that? A little bit more. Okay, now you're right in there. All right, here's the finish pass being programmed. No, we don't want to go deeper. All right. Oh, I think this will be all right. Just say OK. Now I go back to File, Open, find that. St. Helens. There you go. St. Helens 130. Okay. Bring it down here. Let's find X first. I'm going to call that X. Maybe I shouldn't call that X. That looks pretty close. Our Y. It's right about there. Yeah, it's fine. Fine where we're at. Okay, so now X and Y are set. I'm going to find the lowest point here. It's about there. That says we're about 1 millimeter. I will set C right there. Okay. Okay. Get your earring protection on.